Alright, so we're talking to Bill Hoggan, computer science professor. Hey, Bill. And he's going to show some of the toys from the olden days. Not that long ago, really. What's this one, Bill?
Okay, this was what we call a paper tape reader. And this was basically used in the 1970s. And the paper tape reader actually takes, and you have punch holes on there, and you can have 8, 7, or 5 bits of data. And this was just like a streaming tape, magnetic tape, but it was paper. And this unit will either read or punch the tape. And so when you go to run it, you just run a whole roll of tape in here, and it allows you to take and enter an awful lot in. It made it easier than reading in a whole lot of punch cards. Now the punch cards are kind of a history behind the punch cards, because there was really initially 2 levels of punch cards. This is an 80-column punch card, and it's put in Hollerith field. And this card actually has the punches of every character that's available. The earlier one, another version of it, was done by Sperry Corporation. Instead of being an 80-column card, it was a 90-column card, and they used, instead of square rectangular holes, they used round holes. And so this became the universal standard. And they used to have a card reader you used to stack cards in. Well, this happens to be a typical slow 30 cards per minute reader. The cards would be stacked, so you'd have a pack of cards in here. This reader would take them, and the brushes right here, making contact with this, would be what would read, what holes would be read, and you have a timing wheel that times the 80 columns, and so it would read a card in, read it through here, and then read the next card, all through a timing mechanism. This again was used as a terminal attachment to desktop computers. So in other words, we really didn't have the capability and sophistication we have today. This is what they had. You had the computer, you'd have the paper tape, you'd have the card reader attached to your desktop computer. Your desktop computer would then give controls, and then you'd read the cards. Very slow. The real problem is if you dropped your cards, they'd be all out of order, which makes things very awkward. The other thing is they used to design all our computers, and they used to have core memory. And this is a card that has core memory. There are 4 wires that go through every core. And these were done by people who used magnifying glasses, and they used to hand weave these. So you have an X and a Y direction for positioning which core you wanted to, and then you have a wire that starts at one end and goes through every core in one direction. That's a sense wire. And then you have another wire that goes through every one, which is an inhibit wire. So you position which core you want to talk to or read from, you sense it, and then you inhibit any of them you don't want to have read. This is how we used to do memory. Now, if you look at it today, we have all our memory on a little stick card. I have a computer that was done in the year 1980, in that age period, and we used to use a card about, a foot square, and you used to plug in a memory chip in sockets, and the card I had was 2 meg of memory on a card, a foot by foot square. Now we can put a gig of memory on a little memory stick about so wide. So we have come a long ways in our technology. Anything else? Back in the 70s, we ended up by really programming our network terminals or our computer terminals as somewhat of a standalone device. So we had card readers we could attach to them, we had paper tape readers, we could attach printers, we could attach a memory, just like the cassette memory that you have that you play music on, the little one you put in your car with the little spindles and it's about this big. And what we had to do is the format had to be in either a 8-bit or a 7-bit format. 8-bit was EBCDIC, which you don't really see anymore, and the standard was ASCII, which is 7-bit code with 1 bit as parity. So we ended up with 8 bits. We had to do everything in assembly language. We had to write the code to send it out on the line. We had to write the buffers to put things out to devices. We had to select the device. Our interface is strictly with the operating system. There was no layer structure. Every company had their own terminal. You had to write the code for each individual company's terminal, which meant that either you had to have an emulator or you had to go in there and write it. I had been sent to many companies like Ford Motor Companies in Detroit. I was sent to an insurance company in the state of Washington to teach the programmers how to program our computer terminals and the devices. So it was quite a challenge because everything's done as assembly language. You did bit manipulation. You had to worry about what happens if you had to know the difference between a 1 and a 2's complement machine. Some machines were done with 1's complement, which meant that if you ended up with all 1's in a memory location, the minute you read that into a register, the computer was very nice to you and converted it to all 0's because all 1's was treated as a negative 0 in 1's complement and didn't like a negative 0, so it made it a positive 1. So as you read characters in, you had to be careful that if you ended up with delete characters, which was all 1's, you didn't get it changed to be a positive 0, which was all nulls. So in your programming back in those days, you had to be very careful of whether you're running off a 1 or 2's complement machine. 1's complement machine, you had to be worried about the data, how it was formatted, how it came in, what you send out, because the machine would do things for you which you really didn't like. So there was some problems with this. But we would spend probably doing the communication handlers somewhere between 9 months to 1 year in developing them and testing them. Every operating system had to have their own communication handler. Where today, with the layer structure, we have TCP, it's standard. We have IP, it's standard. Those are common across various operating systems. We don't have to program them. The only thing we have to worry about is our applications now, if we change our applications. But everything down below the application is standard. We can move from various PC-driven manufactured machines. They're all standard. They all run. We don't have a problem with them. Even Mac now is set up so we can run common software.
I can talk during this too because we're just talking, right? So you were working for Sperry at the time?
Yes, I worked for Sperry from 1969 through 1987. At that time, I came to teach here at Weber State in 1987.
Okay. And you were doing a lot of networking stuff in the days before people even knew what networking was in the general public, right? I mean,
That's right. It was very interesting that we learned how to debug over the telephone lines, or what we call them WATS lines, leased lines. My mainframe was back in Minnesota, and I would run on a dial-up connection, and I'd run to the mainframe back in Minnesota, and then I could interface, look at the screen, and see what was coming back and forth. But in order to to take a memory dump to find out what was happening or where my problems existed, I ended up by having to write code in my, what we call them, our communication driver, to actually dump the information onto my computer screen so I could debug it. And it was all done in machine assembly language, so you would be looking at machine code. And you'd have to know what location in memory to go to, what location to print out, and then be able to read machine code and decipher it. And one time it was interesting that when I did this, I actually overwrote part of my communication handler because I'm running in privilege mode, and all of a sudden I hung my terminal. So then I figured out different ways of doing it. We had a remote printer, and I would just have my dumps print out to remote printer, print them out, and then I would analyze them, desk analyze them. I would take and draw up the diagrams for the software on this. Actually were drawn up on sheets of paper using flowcharting, and they were drawn on sheets of paper probably 4.5 to 5 feet long, and I had probably about 4 or 5 pages of those. So when you went to debug and troubleshoot, you would go back to your flowcharts and look at them.
And your flowcharts were written in hand, by hand?
By hand. Everything was done by hand, and you had a template, and you used the template. Let me turn it off. Utah, the master's degree in computer science, I went to work for Boeing. And I was working on a missile project, and my assignment was to test the missile computer. All they had on the missile computer was the logic equations of the computer. From those logic equations, I drew up what the computer looked like. And these were drawn on regular newspaper type paper, and this became, that shows the memory. It had 2 registers, an A and B register, and then it had all the timing circuitry. And right here is all the timing circuitry that tells when you send signals out to every one of the chips inside the computer.
Well, we're really looking at pretty basic gates here. These are AND gates.
These are AND gates and regular flip-flops.
Flip-flops
and you've got some NAND gates over here. These are NAND gates. Basically, they're built with NAND gates.
And those are the flip-flops?
And they were just the JK flip-flops.
Wow. I'm looking at this thing. I don't see an OR gate either. I just see NAND gates.
They're all AND gates.
And this is is the core memory over here?
That's the core memory. That's just one phase of the core memory.
Wow. That's amazing. So you had to draw this out?
I drew it all by the logic equation.
So you basically reverse engineered this device.
Yeah. And the interesting thing on it is, here's the adder, and you can see where they have the 4 adders, 3 full adders in there. So it was really kind of interesting to see some of this. And this was actually comprised of 2 sheets. And there's the rest of the circuitry. Right here, get it. Right at this point is the crystal oscillator. There's the crystal oscillator of the clock. And from there you have all your countdown registers. It goes into a flip-flop registers, and from these flip-flop registers send all the timing signals out to the computer.
So am I looking at something that was drawn by hand?
It was all drawn by hand. This was drawn on regular newspaper size paper, which is twice the size of this. So this has been photo reduced down. When I met with the company that actually developed the computer, they asked for a copy of these diagrams because their engineers had left and all they had was a manufacturing diagram of what the boards were. They had no idea what the internal copies or what the internal of the computer did. So Boeing actually gave them a copy of the drawing of their computer.
So why didn't they have a drawing in the first place? They were just rushing it out the door, or?
I don't know. No one would tell me. And as a consequence, this was quite a challenge to go through and do all this. And my management was, quote, very impressed that somebody fresh out of school could do this. And the unique thing was I had never seen a complete diagram of a computer put together. Even in our modern day computers, they will give you block diagrams, but they never show you how these things are put together. They don't show you the wires. It's just the fact that we have signals going out, and they're all clocked at a particular time. This is the interface going out. This is a basic flip-flop, and this is the basic diagram I put together for the AND circuit. This particularly shows a 4-input AND circuit.
And these are your registers, essentially?
Well, this is the signals. In other words, I have to go from one place to another. So in other words, this was just taking the output signals that come out of various outputs here. These are the signals here. So this will go to another drawing. So this tells you what the signal names were and what the positioning they were on the drawing. So you could reference one sheet to the other.
So was this part of the K-Pro, the floppy drive?
No, actually, well, anybody that had a 5 1/4-inch floppy. Now we're using 3.5-inch hard one, but the floppy was just a piece of magnetic material inside a sleeve, and the sleeve would allow you to read. Basically, they were set up to read one or both sides. And the old initial Apple machines would only read one side of it. And the disk actually was formatted, both sides were formatted. But if they had one side that didn't meet the specifications, they sent it out as a single density drive, and they had a notch in the sleeve if you could read both sides. And they charged more for the double density, the double-sided floppy disk. Well, we found out that you just take one that has a notch, mark it out, take a regular hole puncher, punch that area where the notch is, and now you had a double-sided disk that you could use. So it was a way that you bought single-sided disk, and you could run them as double-sided disk, and you could double what you could put on them.
So dual density was what? 256K or 128K? It was not big. I remember that.
I think it was about 256. I'm not sure.
Yeah.
I can't remember.
Well, they probably changed it too, right? There was some several.
Yeah, I'd have to go back and look because I think some of them may say on the floppies. I've got a whole ton of floppies.
Yeah, back when floppies really were floppy.
Yeah, they were floppy. Matter of fact, when I first worked at Sperry, they had an 8-inch floppy. And the secretaries used to use an 8-inch floppy for their word processing. And one of the typical things one secretary did was, and we have them today where the secretary has the little sheet that they hold their paper in while they type. Well, instead of holding it with the little slide bar, they used a magnet that held the paper. And so the secretaries from time to time would put the 8-inch floppy on their little typewriter thing and put the magnet on them. Then they wonder why the floppy would never read anymore.
So they stuck the thing to a file cabinet with a magnet, essentially.
No, they on their desk when they did their
on
typing,
their
they just put the disc there because they were going to use it later.
Oh, that's funny.
And they would go put a piece of paper to type on, then you'd put the magnet on the piece of paper to hold it with the disc behind it. The magnet is a form of demagnetizing or changing the magnetic spots on the disc. They used for printer. This was the printer paper they used to use, and these printers used to print about 600 pages per minute. And they used the different color bars so you could kind of follow your lines.
So you've got, this is a big program you're looking at here, basically an assembly language
It's an assembly language program.
And what machine is this on? Do you remember?
That strictly is just a PC. This is the earlier version.
Oh, it's the
This is
turbo assembler.
Yeah, it's a turbo assembler, and it's probably for a 186 or 286 PC. Is what it was written for.
So you had one of these wide printers off the side of your PC, basically.
I did. Plus, that's what your computer center had. Computer center had a great big one, but I had a small one, just like a. If you were to get a wide printer, 128 column printer, that's exactly what it is, and they would print at 30 characters per second. Oh, 30 characters per second. Extremely fast. Our printers today print at, our low printers on our computers will print at 30 pages per minute. These are printing at 30 characters per minute.
So how does this thing go together? You plug it in, plug the keyboard in.
Plug in the keyboard, being a luggable. This fits like this, and that is just a regular telephone cord, 4-wire telephone cord.
You turned it on and it seemed to come on pretty darn quick.
Oh yeah. You just put your disk in and loads the operating system. It's there. Do a directory.
So you got a lot of stuff. Now this is basically on that disk A.
Yeah, this is the CPM operating system. So that gives you all the commands that your operating system, if you want to use that.
And then if you have an application outside the operating system.
Well, you can actually, even if you want to, take, and in this case I put the application in. And now you just go there and you've got the application. Here we have MBasic, so if we want to run the ladder game, you can just do MBasic.
That's an old sound you don't get to hear too much anymore.
File not found.
All right, so you have just the disk in A with the several basics on it and some of the games on it.
Yeah. We didn't have to, all you had to do was type in the name of the game. It's an A.
This is Ladder, a game in which you have lads.
This is next one. Is this one.
Oh, catch 'em.
Now, what does this look like to you?
Looks a little bit like. That's funny. So you got a little Pac-Man copy here. So I take it you have a C and you're moving out of there. You're using keypad 4 to left, 6 to right. Wow, he's moving pretty slow, isn't he?
Yeah.
Nice try, pal. Well, that's pretty surly little game.
Lose.
And so we're saving right to that disk.
6 right. Oh, 6 goes right. Should be the same. Yeah, it's the same. That goes left. 6 goes right.
It doesn't seem very responsive, does it?
It goes down.
Oh boy.
8 went. This is working a little different.
Those little A's seem to move faster than you do. Ooh. This might take some getting used to. Now this program's actually in BASIC. It's a text file, right?
Yeah,
So I could go and I can modify the program if I wanted to.
I'm sure. This is oh, I know. Let's try that.
It's amazing. Limited sound effect set for this thing too, I guess, huh? Careful, Bill. They get confused when you go through that door. Oh, this is nice. You're lining them up. Ho ho! I know the momentum really kills you. There you go. There you go. Get him, get him.
If you just take and hit it, you can set your direction.
Yeah. And then if you time it right, you can take that turn. But sometimes you don't time it right. Like that. Oh, nice. Oh. See that? You get a little extra time if you go through the portal, which is end of game. Alright, so basically you've got a disk. It's got three, and this is what's amazing to me, is you've got 3 basic programs on there that fit on there, along with all these games. And this is what, a 128K disk or something?
64. Well, these discs, I was doing some looking at, and the discs come out at, actually, if you looked at them, the size of the discs are basically 196 and 392. So a single-sided is 192. The double-sided is twice that, and then you have a high density that gets you up to 1.2. These are interesting. If you look at these 2 discs, one has a square cut, the other one has kind of a circular cut in here. This disc was initially a single-sided disc, and the old Apple computers would run under a dual-sided disc, so they've found out that if you cut a single-sided disc and just put this notch in there, you can run it as a dual disc. Kind of a little sneaky little thing that you learn how to do. Basically, how the K-Pro works is you put whatever you want to do in one drive. If you want to save stuff, you put another blank disk in your B drive, and you can, if you were using like WordStar, you can create your file, and then you can save it to your B disk. Or you can save it if there's space on your A disk, you can save it to your A disk.
So you don't need the CPM operating system on drive A in order for anything to
No.
work on this K-Pro.
It automatically loads. I was reading the manual, and it talks about that it does have some ROM in there, and so apparently the CPM is automatically loaded in there. Because if I did a boot, this one we didn't even load it, and we just did a warm boot, and it brought it up.
And it brought it up quickly, too.
So if you look at how quick it comes up, pull the disk out, you go to a warm boot.
Now, when you say warm boot, you mean...
Well, a warm boot is just like on a normal PC where you push the reset button.
Is there a reset button in the back?
Yeah, there's a reset. If you go to a hard, this would be just like bringing your system down, powering your system down, except there isn't a shutdown. The only thing they require is you don't leave your disk in your system when you shut down, because what happens is the head crashes.
Also, this doesn't have any way of saving the heads.
No.
It's completely power off.
That's right. And if you lose power, you get a head crash.
So even with these little floppies, you can get a head crash.
Yeah. So basically, we've got the K-Pro system in there. If we just put an A disk in there, if you were to look in here, you can see that the disks are spinning automatically.
Ah, interesting.
So you can see the bottom part spinning. And so when you put this in, close the door, brings up, and so therefore this is K-Pro 4, has 64K, it's running CPM version 2.2.
Well, that's pretty quick. So when you put on that switch, it's basically turned on.
Yeah, because it's a
As
ROM.
And as soon as that, basically it's the screen warming up more than anything.
Yeah. I mean, these are faster than our modern computers as far as having your operating system up and running. The minute you close fire it on, you're up and running. You're ready to go.
Well, I guess they don't have all this overhead of systems or things like, making sure that the heads don't crash on the disk and all that.
Oh, yeah. Really interesting where we've come from. And yet, size-wise, it's about the size of a modern PC. It's a little bit bigger than our laptops now.
Yeah, a little bit bigger. It's what you call a luggable.
Luggable, yeah.
Not a portable.
But it's really kind of interesting.
Could you put that on your lap, you think?
Well, it weighs. It's got a little bit of weight. You carried it in, so you know how much
it must be
weighs.
at least 20 pounds.
Well, I'm sure it is. The first one I had was this cable actually shorted out on me. But that's just a regular old telephone, so I just went and took the cable from a telephone to the head, the mouthpiece, and put it in, plugged it in. So you didn't have to buy any special cables or anything. You didn't have to have anything unique.
So when you bought this thing, you bought it with all this software that I'm seeing up here on the table?
Yeah. Everything came with it, except we had a basic ones, and you have a few games and stuff that we got. But most of this was the games and stuff are all CPM driven, and so my boy had a friend that had the Apple machines. Now, back in the early 80s, Apple donated Apple computers to the schools. And so the students would go out and buy Apple computers. And so they would get these games. I'm not sure where they got them from, but because they were CPM, the CPM was compatible, my boy would get copies of them from the neighbors, and then they'd come over and run them. And so you have an awful lot of discs and stuff. And this is an adventure game. They have some interesting games on here.
And this is originally from an Apple machine? An Apple II, I guess, right?
Yeah. And this is adventure. And I'm not sure quite how this one works. Whether we can just do an ADVENT.
You got a COM file there.
T.com.
Maybe without the extension?
That's the problem is, these are ones that my kids had, and I have no idea how, because I was not into a game playing, never have been.
You never know how these things are supposed to work. Not quite like the same as clicking and
click and point.
Click and point, yeah.
They're all a little different, but as you can see, there's a whole stack of various discs that my kids used to do their homework on.
Now, why did you get this machine in the first place?
Well, we didn't have a computer, and when I first bought it, I was working at Sperry, and we had a person that worked at Westminster College, and through Westminster College, we were able to buy the computers, and I think I paid about $1,500 for it. About 3 or 4 years later, Sperry came out with their PC, which was a leading edge, and that one I paid, with all the additional stuff that I got with it, was about $2,700, and that was a 286. This is an 8080 base machine. So, we've come a long ways, size-wise, capability-wise, and price-wise.
So Sperry had its own PC for a while.
Yes, they were quite interesting. IBM came out with theirs, and Sperry, initially I was sitting at a marketing meeting, and the marketeer made a comment that felt that PCs would never find a place in the home, strictly be used for business. And I leaned over to the person sitting next to me, I says, isn't he out in left field? And Sperry came out a few years later and says, we may be late into the marketplace, but we have a good machine. But all they did was go over to Japan and have them add a few modifications to the machine that was already being built there, and then they marketed it. Because if you were to buy the leading edge machine, the only difference was Sperry had a little bit more memory and a different power supply.
Now, was that what it was called, leading edge?
That was a company. That was a competitive. So if you went over to a computer store, you would buy a leading edge computer. But there wasn't any difference really between the leading edge and the Sperry. Sperry just had their name put on it. Of course, we see that every day. One or two manufacture, and everybody else puts their names on it.
So you're sitting in this marketing meeting, and you already have a K-Pro at home, and he's telling people that
that's right.
PC's not going to be in the home. This is after the Apple II is already out there?
Yeah.
Okay. So I'm assuming he has a long and gloried career at Sperry as a marketing individual.
No longer was he ended up in the marketing. He ended up in the development as a continuation support manager, and that didn't last long either. So as far as his technical capability, his managerial capability, and his foresight or forecasting, didn't have it. All I know is at some point in time he was no longer in the Salt Lake office.
Now this K-Pro, when it came out, this K-Pro this is an earlier machine. Obviously it's portable or luggable, as you say. I guess it's coming out about the same time as Apple II, the Atari 400 maybe.
this is a K-Pro 4. They have a K-Pro 2 that was his predecessor.
Mm-hmm.
And then they came out with a K-Pro 10. According to my understanding, there is one of these luggables, I don't know if it's K-Pro 2 or K-Pro 4, back in the Smithsonian.
Mm-hmm. Now, when you brought this home, you said, well, you don't have a computer in the house, and you thought, we should have a computer in the house, or?
My kids, you know how kids are, they wanted something to do their homework on, they wanted something to play with, and I also felt it was good for them to get used to having a computer in the home and be able to have the interaction with a computer. And I look at it today, when I was talking to the owner of Murdoch Chevrolet, which is quite a bit older than I am, he made the statement that his age, they're scared of computers. And I told him, I says, you know, look at my kids and his grandkids, with all the video games they play, they are very accustomed to the use of a computer. So they are not scared of computers.
So they actually did their homework and stuff on it, like
yes.
Typing a page. You had a printer that came off this, didn't you? Like a dot matrix?
Yeah, I have a dot matrix printer. It's just I have to dig it out. I can go through these floppies, these 5 1/4-inch floppies, and I can find my children's homework still on them.
Do you remember what year you got this?
I purchased this probably in 1983, 1984. I bought my Sperry PC in probably 86.
Did you ever end up using the K-Pro for work?
No. It's mainly what we used an awful lot for was to do text editing. It has a program called WordStar on it, and it's the same as, you know, Microsoft Office, WordPerfect. And it has control characters, edit lines, delete lines, add lines, insert, and so forth.
It uses key sequences, right? Character sequences for
yes.
the commands.
Everything is key sequence, and the WordStar puts out the very top of here a list of commands, and then you just have them available to you, and you just, if you want to do something, then you just type them.
Notice that this keyboard doesn't have any function keys on it. It does have the cursor keys, though, which may have been a later addition. I don't know.
Well, we do have a control and delete. We don't have an alt.
No alt.
You have an escape.
And a lot of stuff, like what we were talking about earlier, to get out of a program, you might do a Control C or a Control Z or something along those lines.
Well, the manual says Control C, but for some reason that doesn't seem to get us out. So the quick and easy way to get out is you make certain your floppies are out and do a warm boot. Just push the reset button.
Always make sure you got the floppies out. Did that ever not happen?
Yes, and if I've lost stuff that's on the floppies, yes.
So here it is 2006, and most of these, if not all of these disks are actually still working, which is pretty impressive, I think. And
I'm surprised.
And this machine is still working, too. Do you turn this thing on every once in a while, or just to show students? Or?
Well, I turned it on to show Dave. So it hasn't been powered up for probably 25 years or whatever. 10 years, what would it be? 85, 95, 205? Probably at least 20 years, probably.
Wow, impressive.
Box. I don't know if it's in this one.
What are you looking for, Bill?
I found it.
Oh, wow, look at all those cables.
I used to run the thick wire through here, and it has what's called a tap, which is called a vampire tap. Little pin right there.
Vampire tap.
Yeah.
So the wire goes through there.
Across here.
You put the hole through.
You put it here. It's coaxial cable. It's a thick wire, which is about this big. And then you have a 15-pin drop cable, and this goes down to the network card.
So this whole thing is a vampire tap. This
is your transceiver
piece,
receiver. And it gets its power from the computer. So this goes down to the network card, gives me power, and then it has your data signals and stuff are through here, and all it's doing is taking and pulling this information off an Ethernet cable. And these used to be put up in the ceilings, and what happens is with the cable, if they didn't put straps on the end, it would hang down and it'd break a connection. Now let me do some other things for you. Tie this in more further.
Well, that seems like a pretty big piece of equipment.
Tie it in, you'll see. This is considered a piece of thick wire cable, and thick wire comes in 3 colors. It comes in black, yellow, and orange. And this would actually just sit right in there. Put that in, then you take and tighten this down, and it will make connection. This is the original transceiver receiver. This one is now a smaller one doing exactly the same thing. It has the vampire tap going down here into it. The reason why there's 3 different colors, black was a rubber cover, which was basically used for regular in building. Yellow was a plastic cover for oil and water protection. And the problem with plastic, if you're in a fire, it would put off a toxic gas. So then they came out with an orange, which is a PVC plastic, a PVC covered one, so it doesn't put out the gas. From that, instead of going to the transceiver, and this is a network card, and so from here we would have a cable going down to network card, which is fit in here. So this would be a 15-foot cable coming down from the ceiling or where the transceiver. Then we went over to what's called thin wire, which is flexible, smaller, and it just went into, again, into the network card. But the problem with the thin wire is this was kind of a serial because we came in, went through a T connection, went out to another one. So we've gone to a very stiff, large transceiver cable to a very thin, flexible, to a network card, to finally we have gone to various twisted pair wires, which we now go through a hub. And these are just some category 5 and category 5/6 wires, and that it just depends upon the number of twists you have per inch. And then we just have the regular RJ45, which goes into a hub. So really what we've gone is from thick wire, thin wire, to twisted pair. And then we have now gone the next way. We have gone to fiber. So if we really look at it, we have a whole way of doing things, and this is just a cable, multi-cable fiber, which you can use to see things through with. One other one I want to show you.
Is that a fiber right there?
Yeah, these are fiber.
might not. Bill, what's this terminal here?
That is a what we call this is a 50 ohm resistor. And the reason why we have those, both your coaxial cables have to have a 50 ohm resistor at the end, because as the signal goes down the line, if you don't have a terminator, the signal actually will reflect itself back. So the whole purpose of the terminator is to take and keep the signal from reflecting back, so it doesn't look as if there's a collision on the line.
Now, a cable like this thick cable, this could essentially be strung across. This could be strung around a whole building.
They were.
And
this building here had them all the way through here when I started here.
And it's the same cable, the same physical cable. That's
Yeah.
being strung.
And what happens? These transceivers are set that they have to be spaced 8 feet apart. And the old black cable used to have it marked every 8 feet.
Now, this is a different fiber that you're looking at?
Well, this shows you, originally fiber wasn't this flexible. And so this one is such, and I don't know if you could.
I think there's a little red light in there. Hopefully it's not burning out my lens, actually. So basically you're shining a laser into this end of the flexible...
Yeah, just a laser pointer.
And then we're seeing it on this end here. There it is.
This is full string of wire. At the University of Utah, they actually went in and put the fiber, and you've seen these on the roads where they have this big plastic, and they put in. Well, the University of Utah was the largest amount of cabling they put through there, and then they shoot the fiber through with CO2. And then they had a wiring closet where they converted the fiber to twisted pair of coaxial cable. And when they first started that, they had to allow enough space for that fiber to make it bend this big, because it was a glass shielded fiber and they couldn't really bend it. Where nowadays we have this, they actually have the cable comes in and these plug into your patch cords.
So fiber was pretty fragile when it first came out.
Fiber was very fragile when it first came out. When I did some teaching up at Thiokol, they had the fiber going underneath the ground, and it'd come up for repeaters. And they said if you look real closely, you can see where the cladding would run down. And so they had to be very careful with it. And it was also hard to patch. And now when they patch fiber, all they do is they put a patch on here, and they have an alignment, and they have the patch just has an alignment bar on it, and you just line the alignment lines up, and it patches it. So it used to be like $85 to make a patch. And now you just buy the unit and do it yourself. You don't have to have anybody special doing it.
And how do you tap into it? There are taps to get into the fiber?
Well, these are the taps to fibers. You just put this. Can you tap into physically the line? No. You've got to go into a connection, just like a hub or a switch or something. So you have to have terminating points.
So there was no optical version of the vampire tap, essentially?
No. Big magnet. And what we used to do on that is when we used to write things, you could take 10 floppies and just take the magnet and run over them like this, and it would demagnetize the floppies so you could reuse them and just destroy all the information on them.
You got that from Sperry?
Well, I was doing a software manufacturing over that, and I dealt with 3M Corporation, and 3M gave it to me.
Okay. Was it used for secret material sometimes to get stuff up disc?
All I used it for was to wipe out discs, because if we actually had to rewrite things, it's a lot easier to make certain we cleared out the discs, make certain they were completely scrambled.
Here's the original BNC connection, I guess, with the Ethernet card. And that's how it would plug into
this goes on to another. This is called a T connector. It's got the terminator. This goes on to another T connector.
But you would often have the cable running through.
Well, this is if you did that, if you ran it through, it's done like this. So that goes from one network card to another network card. Now remember, with the Ethernet, it's just continuous. You don't have a master-slave. You don't have a originating. In fact, they're all broadcasting. The only problem that you have with the thin wire is many people, when they add a new one, they would take the cable and they'd pull it off from here. Or they would take and, in order to get that off, they would take and, because they used to be screw connectors, they would take it off of they'd pull it off of here, and then you'd have reflection because there isn't a terminator. And so people, you have to be careful when you use the thin wire, adding or taking out one, because this used to be kind of a cumbersome type situation.
And this is just a small version of what you were talking about before with.
Yeah, this is a 50 ohm terminator for what we call thin wire, and this is the 50 ohm wire for the thick wire. You know, also it says, you can't see it, but it says 50 ohm. Now we did have, this one is, these have both 50 ohms on it. We did have one time that they gave us a 75 ohm, and they actually did work for a short distance, but once you got a further distance away from a network card, they wouldn't work.
What is this unit here? Is this another vampire tap essentially, or vampire tap and
Oh, this
transceiver?
was just it just wasn't complete. This was just a partial one. So it's the lower half of that right here. So that's just this part.
And who's making this? This is a digital?
Yeah, these were made by Digital. Ethernet transceiver. You got to remember, Digital was one of the initial companies that came up with the Ethernet specification. There was 3 companies. Digital was one of them. I think SDS, and I can't remember who the other one was, but Intel, Digital, and SDS were the ones that came up with the original Ethernet specifications. And they had a book, and it's just strictly like an 8.5 size book. They came up with the original one, and then they came up with version 2, which is a blue book, and 90% of it is all hardware. It tells about the hardware. Very little about software. And so you'll find that you'll see the word Ethernet 2, and you'll see IEEE 802.3 Ethernet. 2 different protocols. They can run on the same line, but if I'm running Ethernet 2 between 2 terminals and another terminal comes on and runs IEEE 802.3 Ethernet, they won't be able to talk. And the original cabling, the black wire cabling, is IEEE had a 4.05, and the original one asked for a 3.95. So actually the cabling has different sizes. So when you go into Vampire Tap, you could end up at a point where the Vampire Tap would either cut the wire or not reach it.
So you also have said you brought something else out. You brought a couple boards for.
Well, this was just a board that handled